I wanted to give you a little bit of extra material regarding the use of pointers in C. So what are pointers, how do we use them, and why do we care? So let's start with a fresh microprocessor that we have just turned on. We've just come out of reset, and so our program is about to start executing, and we might have some memory laid out like you see in the table on the right. So just we're looking at here a small portion of the memory addresses hexadecimal 10 through 14. And right now all of the values are uninitialized. I'm going to be using an 8-bit microprocessor today just because it makes the addresses a bit shorter to write. So the first thing that we might do in our code is declare a variable. And so the compiler may choose to place that variable, let's suppose, in address hexadecimal 10. And the value that would be located in that address will be hex 41, which is the ASCII code for capital A. Now we allocate another variable, and we see that that's probably going to be placed in the next location in memory, as you can see on that table there. Now let's declare a pointer. And so we've declared a pointer, but we haven't initialized it to a value. So notice over here that right now this value is uninitialized. We haven't actually specified what value is going into that yet. But we know we have this pointer, and it's a variable like any other, so it takes up some location in memory. So it has an address that has been allocated to it by the compiler. So now let's initialize that pointer. And we're going to do so with this address of operator. So this address of operator is this little @ symbol here at the front. And so what we do is we take the address of a variable that we have previously declared. So in this example, we're taking the address of the variable letter 1. And we notice that the address of that variable is hexadecimal 10. And so that is the value that will appear over here in the location of memory where our pointer is being stored. So the contents of our pointer is now the address of variable number 1. So now we can use this, we can examine the pointer. And so if we were to call printf function like this, the %x here means print out hexadecimal notation. So we're printing out hexadecimal notation of the pointer itself. We're just printing out what is the value of that pointer. Well, what is the value? We look over here in our table, we see the value is 10, hexadecimal 10. And so that is what would be printed out by this line of code. On the other hand, if we dereference the pointer, so notice here we have this asterisk. If we dereference the pointer, then we follow, we have to actually go through now and look at where this pointer points. So the pointer we're looking at is here. That points to this location in memory. It points up here. The value that is in that location, moving across to the right here, is hex 41. And so that means that the thing that will be printed out by this line in printf is actually hex 41. So this is what you need to pay attention to. So let's run through that one more time. We've got the pointer itself, right, which is located here, containing this value hexadecimal 10. But the pointer itself, we're not interested in the pointer itself, we are dereferencing it. So dereferencing here means that we go to that location and then look at the value that is contained within it. So we're looking at whatever is in location 10. So that's how we would dereference. We would examine, we would access the variable that the pointer actually points to. Which means that we can use it to modify another variable. So in this example, we're putting the dereference operation on the left-hand side of an assignment operation. So we're writing into something, we're modifying a variable. What are we modifying? We're modifying the memory where this pointer points. So looking again at these arrows, the value is 10, we go to address 10, we look at the value, and that is where we write. And so what we've done is we've modified this variable. Okay, we've modified the variable letter 1 with the use of our pointer. So why would we want to do this sort of thing? Well, one example is multiple return values. So C functions have only a single return value. Sometimes it's important to actually take out multiple values or return multiple values from your function. So for example, in serial communications, you may need an error message, an error status, or was something received, and also the actual data that was received. So in that example, there's two values that need to come back. So how do we implement that in C? Now, of course, if we talk about other languages, for example, MATLAB, sometimes there are multiple return values supported directly by the language. So here's some MATLAB code that will actually define a function that returns two values. And so something like MATLAB just supports this inherently, but C does not. So the question is, how would we translate this MATLAB code into C? The way that we would do that is through the use of pointers. So left-hand side is the MATLAB code, right-hand side is the C code that uses pointers. And so looking at this here, we're declaring our function. Notice that we don't actually use the return value, no explicit return value, we've just put void in here. But now we're passing three arguments. We're passing two pointers, we're passing the actual input itself. And the pointers are of type int pointer. And then what we do is we use those pointers, we dereference them, we write into the address where they point. We write into the address where they point. And so the way that we would call this in our main code, first of all, we declare the variables, and then we take the address of them in order to generate a pointer that points to those variables that we have previously declared. So that's an example of how we would use them and why we would be interested, because of multiple return values. Another example for why we're interested in using pointers is to generate data structures. So this example that you see here is a data structure called a linked list. The idea here is that we have a structure, which is this block that we've drawn here, which contains a value and it contains a pointer to the next item in the list. And so then if we want to proceed to the next item, we just follow the pointer, and that gives us the next value. And then we can continue going. And you can see that with a structure like this, you can just link together as many items as is required. We can just continue adding new items and setting the final pointer to point to the next item in the list. Now, by convention, with a structure like this, we would set the very final pointer to this value null, which would be a byte of 0 or an address of 0. And that would simply indicate that we are at the end of the list. So we'll come back and talk about data structures a bit later on in the subject, but I just wanted to give you the hint. You can kind of see intuitively how this would work, that we're using pointers to actually generate these more complex structures. So let's wrap that up. Pointers give us access to arbitrary memory locations. We generate pointers from a particular variable, so a pointer that will point to any variable that we like, by using the address of operator, which is the AND symbol. We dereference a pointer, and dereferencing simply means following where it goes. Where does it point to? With the asterisk, we put that at the front of the pointer. That means that we're dereferencing it. And some examples of where we use pointers include multiple return values and also in generating data structures such as arrays and linked lists. And there are many others, tree structures and so on, that people can build with the use of pointers.